binary search. Binary search, what we do first, if the array is not sorted, then first sort it, then use binary search. So array should be sorted, and after that, what is input a sorted array of n element and x element which need to be searched. What is output? It will return position of x, and if x is not found, then return -1. Not found, then return -1. So suppose we have input like array. This is, we have index 1 2 3 4 5 6 7. So first we need to search 40. So first we will calculate the mid element. So mid, first and last 1 plus 7 by 2, that is 4. So what is on the fourth position? In fourth position we got the 40. It means when middle element is x, that is called the best case. So how we can write the binary search? Binary search array, first index, last index, and the element which need to be searched. So first we define integer mid, then we cross check if I is equal to j. Then if array of I is equal to x, then it will return I position. That is only one comparison. Best case, we can say order of 1. Else return -1. Else it will calculate mid. Mid is equal to I plus j by 2, and if a of mid is equal to x, then it will return mid. Else if a mid greater than x, then binary search a I index mid -1, because it is greater than mid, so it will go on to the left hand side. So mid -1 comma x. Else binary search array mid +1 j x. So then closing bracket. So how many comparison will occur? Because here we divided the all thing in by 2, so tn by 2 comparison. Here also tn by 2 comparison, and here we are cross checking that is greater than or not. It is only one comparison, so order of 1, that is we can say constant. Here also we can say one comparison, so order of 1, and here what we are doing, we are just dividing it. So in that way, if we see the recurrence relation of this, then what it can be, order of 1 if n is equal to 1, and order of 1 from here, then order of 1 from here, and order of 1 from here, order of 1, order of 1, order of 1, order of 1, order of 1. So plus tn by 2, tn by 2. So but both will not function, else is there, so only one will work. So plus t n by 2, otherwise. So we can simply say tn is equal to tn by 2 plus c. So if we are going to solve it, so the next time what we will get, tn square plus c, like that it will go. So up to k time, if we will go, then it will be t n upon 2 to the power k plus kc. And if we are supposing n upon 2k is equal to 1, so n is equal to 2 to the power k, and log n base 2 is equal to k. So if we simply put here, then it will be t1, and it will be k will be log n base 2 dot c, because this is constant and this is 1, so simply it will be order of log n base 2. So that is, we can say, the worst case or average case. Now we are talking about, this is the time complexity, now we are talking about the space complexity. So if we talk about the space complexity, so what we have input plus extra. So in input what we have, 2n elements, because array of element in input. So we can simply say, because n element, here we have taken n element, we are supposing, so 2n, because integer type, so 2n plus extra. What we have in extra, we have an extra a, I, j, x and mid, 5 elements, and all are of integer type, so it will be simply 10. So it will be simply 10, or so we can simply say log n base 2, as we have seen from here, and the last log n, it will take time like this. So we can simply say it will be n plus log n base 2, so it will be order of log n. So space complexity will be order of log n, and time complexity, in best case it will be order of 1, otherwise it will be order of log n base 2. So this is called binary search.